All right, guys, today we're going to do solving differential equations. What that means is that we are finding the equation of which the differential equation is the derivative. This part right here, differential equation, means a derivative. Okay, so that's what that means. So finding a derivative. So to do this, we have to separate the variable, which means get the x's on one side, the y's on the other side, and so on and so forth. Let's take a look at the first one. We have an initial condition. These are particular solutions because we do have these initial conditions. So in the first one here, I'm going to multiply both sides by dx. So I end up with dy equaling 6x squared plus 6x plus 2 times the dx. And that's what you want to do. You want to isolate those variables. The y's on one side, all the x's on the other side. So now we need to solve for y. And to do that, we have to integrate both sides. So if I integrate dy, if I integrate the left side of the equal sign, I better integrate the right side of the equal sign. So the integral of dy is just y right now. And now I'm going to integrate each one of those. So I get 6x cubed over 3. 6x squared over 2 plus 2x. And don't forget your constant of integration, c here. So I'm going to simplify this. Y equals 2x cubed plus 3x squared plus 2x plus c. Now I need to figure out what c is. Again, this is called the general solution, but I have a particular solution. That's why we have this f of -1 equal to 2. That means when x is -1, the answer y is 2. So I'm plugging y to be 2 when x is -1. All right, and we end up with 2 equaling -1 plus c when you do the math. So c is equal to 3. So my equation, f of x, is 2x cubed plus 3x squared plus 2x plus 3. What would be this derivative? Well, the derivative should be what we started with, and this is a particular solution because it goes through the point -1, 2. Okay, so let's try the next one on this right side right here. I got all the x's here, so I'm going to multiply by dx. So I end up with dy equaling, I'm going to bring, let's see, I'm just going to bring this variable square root of x to the top, and I get x to the -1/2 times 1 plus 12 x to the 3/2 over 2 dx. Okay, so here I have to integrate both sides. What I'm going to do is I'm going to separate these. I'm going to multiply this times this, and then that's this times this, then this times that. So we know this, the left-hand side is y. I'm going to still keep the integral so you can see it. This times this gives me x to the -1/2 over 2 dx. So that gives me the integral of 1/2 x to the -1/2 dx. There's a plus sign right there. I still get that 1/2 there. Don't forget about that. Okay. And we are going to do this times this. Well, we have 12. X to the -1/2 and x to the 3/2, since they are the same base, we are going to add the powers. That gives me 12x dx. So technically this is 6 right here, because half of 12 is 6. So if I integrate this, I get 1/2. I get x to add 1 to the power, which is 1/2 divided by 1/2, plus 6x squared over 2 plus c. So what do I end up with? Well, this 1/2 and this 1/2 over here cancels out. So I get y equals x to the 1/2 plus 3x squared plus c. Now putting in my initial condition, when x is 0, y is 2. 2 is equal to 0, 1/2, 3, 0 squared plus c. You see that c is equal to 2. Hence, my equation then becomes, I came up with this one, which is x to the 1/2, which is the same as square root of x, plus 3x squared plus 2. All right. So again, it's just a little algebra manipulation. I could have multiplied first, then did separate them, but I just did it at the same time. In the third problem here, you see that we have y at the bottom, x dx down here. So what I'm going to do is I'm just going to do a cross multiplication. This way I get all the y's on one side and all the x's on the other side. So we end up with 2y dy equaling x squared plus 2x dx. And now I can integrate both sides because I have the variables separated. We end up with 2y squared over 2 equaling, we have x cubed over 3 plus 2x squared over 2 plus c. So if I simplify this, y squared equals x cubed over 3 plus x squared plus c. So now plug in the initial condition 0 and 2. So I end up with 2 squared equaling 0 cubed over 3 plus 0 squared plus c. You see that 4 is equal to c. So now I'm going to go back and plug it in. So we have y squared equaling x cubed over 3 plus x squared plus 4. But again, this is y squared. It is not y. So we need to solve for y. So that means I'm going to take the square root of this. So y is equal to plus or minus x cubed over 3 plus x squared plus 4. But now I have to figure out, is it the plus, is it the minus, or is it both? Well, based on this, when x is 0, I need the answer to be positive 2. So if I plug in x to be 0, I get the square root of 4 here, but I need the answer to be positive 2. So I can't take this negative, so the only solution to this is the positive end of x cubed over 3 plus x squared plus 4. No negative, just the positive end. Again, that depends on what this, whatever this initial condition right here is given to us. Same thing with number 4, I'm going to cross multiply. Y dy equaling x plus 2 dx. Integrate both sides. We end up with y squared over 2 equaling x squared over 2 plus 2x plus c. Plug in the initial condition. Negative 3 squared over 2 equaling to 1 squared over 2. 2 times 1 plus c. And if I do the math, well, this is 9/2 equaling 1/2 plus 2 plus c. You'll find out that c is equal to 2. So I end up with y squared over 2 equaling x squared over 2 plus 2x plus 2. Multiply both sides by 2. So I get y squared is equal to x squared plus 4x plus 4. Now this is again y squared, so y is equal to plus or minus that square root. And now I got to check, do I need both the positive or the negative? If you look here, I want the answer to be a negative, so I know for a fact that the answer to the solution is a negative square root of x squared plus 4x plus 4. Okay. So these are the basics. These are the basic ones. let's go a little bit more in depth. Here we go. dy dx equals x to the fourth over y minus 2. Okay, so I'm going to multiply by dx, and I'm going to divide by y minus 2. So we end up with dy over y minus 2 equaling x to the fourth times dx. Well, I'm going to bring this back up here. So we end up with y minus 2 to the negative 1 dy equaling x to the fourth dx. Now I have to integrate. I mean, I can kept it this way or that way. It really doesn't matter. Well, when I integrate, I get 0 because I have to add 1. Remember, when that happens, you know this is a natural log. So this side is natural log of y minus 2 equaling x to the fifth over 5 plus c. Plug in the initial condition of 0, 0. So we get the natural log of 0 minus 2 equaling 0 to the fifth over 5 plus c. So this is the natural log of 2, because the absolute value of negative 2 is 2. So we get the natural log of 2 is c. Okay. So what do I end up with? Natural log of y minus 2 equaling x to the fifth over 5 plus natural log of 2. Okay, I need to solve for y. So I have to get rid of this natural log right here. And to get rid of the natural log, I better e it, meaning e to that power. So e to the natural, excuse me, natural log of y minus 2 equals e to x to the fifth over 5 plus natural log of 2. E to the natural log of something is that something. And e to this power, well, since it's a plus, I'm going to rewrite it as e to the x to the fifth over 5 times e to the natural log of 2, because if they're the same base, you would add the powers. So I end up with y minus 2 equaling e to the natural log of 2 is 2 e x to the fifth over 5. So actually, this should have stayed in absolute values. I apologize, because e to the natural log of that something is that something. Okay, so now we want to solve this. So we have two setups. We say that y minus 2 is equaling to 2 e to the x to the fifth over 5, or y minus 2 equaling to the negative, because inside the absolute value could either be positive or negative. 2 e to the x to the fifth over 5. Okay, solving actually, I should say, y is equal to 2 plus 2 e to the x to the fifth over 5, or y equals 2 minus 2 e to the x to the fifth over 5. So let's check. If I plug in 0, 0, right, because I need that to happen. If you plug in x to be 0, you end up with y equaling 2 plus e to the 0 is 1. So 2 times, so I get y equals to 4. This does not give me 0, 0. But if I plug in 0, 0 here, y equals 2 minus 2, I get y to be 0. So my only solution then is that f of x is equal to 2 minus 2e x to the fifth over 5. All right. Now let's do number 6 together. In number 6, again, I'm doing the same thing. I'm going to cross multiply here. I'm going to get dy over y minus 1, because I can cross multiply and then do it. So you get x squared dx. You get, you know what? Let's rewrite this. Let's just rewrite this. Let's do this. Let's do dy dx equaling, I can rewrite this x minus 2, y minus 1 to the negative 1. I just flip-flop them so the powers be gone, so that'll be easier when you cross multiply. So you end up with y minus 1 to the negative 1 dy equaling x to the negative 2 dx. Again, once I integrate this, as you see, this gives me the 0, so this is back to natural log of y minus 1 equaling, this gives me x to the negative 1 over negative 1 plus c. Okay, so we end up with natural log of y minus 1 equaling when x is negative 2 and y is 0. Oh, I should have plugged in y to be 0 here. So 2 to the negative 1 over negative 1 plus c. So we end up with negative 1/2 here. Natural log of 1 equals negative 1/2 plus c. So we know the natural log of 1 is 0. So 0 is equal to negative 1/2 plus c. Therefore, c is equal to 1/2. So my equation then becomes natural log of y minus 1 equaling, can I just say this, negative 1 over x right here? And c is 1/2. X to the minus 1 over negative 1, the x comes down. So you get positive, but you have that negative 1, so we have that. So now we have to solve this. I got to e it, just like we did here. So e to these powers, you end up with the absolute value of y minus 1 equaling to, well, if I break it apart, e, you know what, here, let's just do it this way. Make it simple on you. Because there's no natural log. You don't have to break it apart if you don't want to. Just makes it a little bit difficult because it's not natural log like this one over here had a natural log of 2. E to the natural log of 2 was 2. But here there's no natural log, so I can write a e to the negative 1x times e to the 1/2, but oh well. We have two solutions. Y minus 1 is equal to this, or y minus 1 equals to negative of that. Okay, so if I solve for this, I get y equals 1 plus e to the negative 1 over x plus 1/2, or y equals 1 minus e to the negative 1 over x plus 1/2. Okay, now I need to plug in when x to be 2, y to be 0. So if I plug in x to be 2, I get e to the 0, which is 1. 1 plus 1 is 2, so that does not give me the 0. So that doesn't work. Here, I get 1 minus 1, so this is my equation right here. All right, so that's number 6. Now, let's do an AP problem. I got 2 more problems for us. So we have to, because that's what you're going to automatically do when you take the test, is that do problems like this. I'll let you know what I found out yesterday when I attended the AP webinar, and I'll give you all the info later on. Consider the differential equation to be this. Find the solution with this initial condition. Find the domain and range, that what we did over here. All right, so I'm going to cross multiply. So let's do part A. We have e to the 2y dy equaling 3x squared dx. That's just by cross multiplying. I'm going to integrate both sides. So e to the 2y, you have to do the u substitution. for this because we want the derivative to give me this. In order to do that, I have to, because the derivative will have that 2 in there. So technically, you could have done let u equals 2y. Du is 2 dy. And as you see, I don't have 2 dy. I got to do 1/2 du, which is dy. So now this becomes 1/2 the integral of e to the u du, which gives me 1/2 e to the 2y. I'm going to bring down this equal sign right here, and I get this is just x cubed plus c. All right. I need to do the initial condition that y is 1/2 when x is 0. So we got, this is e to the first, so we got 1/2 e equaling to c. So my equation then becomes 1/2 e to the 2y equaling x cubed plus 1/2 e. Okay, now I'm going to get rid of the e. Well, before I do that, let me multiply by 2 to make it easier on ourselves. E to the 2y equaling 2x cubed plus e. Now I'm going to natural log both sides because I want to get rid of the e. Okay, so natural log of e to the something is that something. And I end up with natural log of 2x cubed plus e. I'm not going to get fancy and do that. I'm just leave it as is. So y equals to 1/2 natural log of 2x cubed plus e. Okay. So they said find the solution of y equals to f of x. Well, what y equals to f of x? So we have to make sure that we write it in this fashion. Okay. So that's part A. Part B. Find the domain and range of this guy. Okay, well, we know that f of x equals to 1/2 natural log of 2x cubed plus e. We can put this in our calculator, but we should know that natural log has to be greater than 0. So that means this 2x cubed plus e has to be bigger than 0, which means 2x cubed is greater than negative e, which means x cubed is greater than negative 1/2 e. Well, solving for x is greater than the cubed root of that. So I know the domain then. X has to be bigger than this, so the domain is the cubed root of negative 1/2 e to infinity. I can, from there to there, that's what is 0. And I know that my range for a natural log, just in my head, it looks like this. So the range is from negative infinity to infinity. And finally, the last problem, we have an acceleration. The acceleration of a particle moving along the x-axis is time to be given by a t equals 6t minus 2. If the velocity is 25 when t is 3, and the position is 10 when t is 1, then the position x of t equals to one of these. Well, I know a couple of things. We know that v of t is equal to the integral of a of t dt. Well, I know a of t, so that gives me the integral of 6t minus 2 dt. And that gives me 6t squared over 2 minus 2t plus c. So I know that my velocity then is going to be 3t squared minus 2t plus c. And I know the velocity is 25 when t is 3. So 25 equaling, oops, this is squared. So I'm trying to find what c is. I'm going to end up with c to be 4. So that's what that is. So I know my velocity function, v of t, is 3t squared minus 2t plus 4. If that's what that is, then uh, what what's my position function? So which one do you think is going to be? Do you think it's going to be A, B, C, D, or E? Well, if you know the velocity, you can get the position function by integrating that. So that means then if I integrate to get my position, so I end up with t cubed minus t squared plus 4t plus something. That's my position function, which is x of t. Well, that means, oh, the one that fits this is C right here. Now you might be saying, how do they get that? Well, um, because remember, C can be any number. We don't care about C because its derivative is going to be 0. So in a testing situation, if you don't have multiple choice, then this would be your position function right here. And the same thing down here. We have 3 things to do. A particle moves along the x-axis, so anytime t is its acceleration. So we got acceleration. At time to be 0, the velocity is -9. So they gave me both position and velocity. So if they did that over here, I would have plugged in the position number. Part A, find v of t. Well, we know that v of t is the integral of a of t dt, and that is the integral of 6t plus 6 dt. And that gives me 3t squared plus 6t plus c. Okay, so that's my v of t. Plug in the initial condition at t to be 0, the velocity is -9. So -9, 0 plus 0 plus c. So I know c is -9. So my v of t is 3t squared plus 6t minus 9. That's part A. Part B, find the distance traveled for the particle over the interval from 0 to 2. So this is my net distance. And that's the integral from 0 to 2 of my velocity function v of t dt. Well, we just figured out what v of t is. So that gives me the integral from 0 to 2, 3t squared plus 6t minus 9 dt. So that gives me t cubed plus 3t squared minus 9t evaluated from 0 to 2. At the upper limit, I got 2 cubed, 3 times 2 squared, minus 9 times 2, minus at the lower limit, as you see, they're all zeros. And I end up with, if you do the math here, you end up with 8 plus 12 minus 18. And I end up with 2. So my net distance is 2. Find the total distance. Part C, we're doing total. And total distance is the integral from 0 to 2, but now we got to do the absolute value. That means we have to count when it comes back. This is just when it's going forward. I know that v of t is equal to 0 because it told us here that at t to be 0. So I need to know when does it come back. So I need to know when v of t is equal to 0. So that means when 3t squared plus 6t minus 9 equaling to 0. So I can factor out a 3 here. I get t squared plus 2t minus 3. I can divide by 3, so that means I just got to factor this guy out. That's easily factored to t plus 3 and t minus 1. So t is equal to negative 3, or t is equal to 1. So I know it can't be the negative 3, so at 1 it comes back. So my total distance then is the from 0 to 1 v of t dt plus, because from negative 3 to 1, so and they want from 0 to 2, so from 0 to 1, plus the integral from 1 to 2 of v of t dt. Okay, well, I'm just going to use my calculator for this. I can put this in. Well, here's the integral of v of t. Just plug it in from 0 to 1. Get that absolute value if it was negative or positive. And then from 1 to 2, plug that in. You find out that you end up with your total distance to be 12. Okay. So as you see, from 0 to 2, technically was 2 that's going in one direction. 12 is the total distance that when it comes back as well. All right. So I will post some homework problems for you that goes along with this section.